This is lesson 19A in our Foundations of Mathematical Reasoning course. Go ahead and read that first paragraph and answer questions 1 and 2, and I'll go ahead and read it out loud. Suppose you invest $1,000, and I like to write as I'm reading. Suppose you invest $1,000 principal in a 2-year certificate of deposit with an annual percentage rate of 6%, where compounding occurs monthly. And so you've talked about compounded interest, and you've played with it for compounding annually. We've got a change in this lesson, and hence the title, More Compounding. And so this time it's going to be monthly, and so they're going to walk us through some ideas about what does that look like, what do I need to do to make it happen. And so the first two questions, if the annual rate is 6%, then what is the monthly interest rate? And then over the 2-year term of the CD, how many times will the bank pay interest to you? So go ahead and hit pause. Go ahead and put down an answer to those two questions, and then come back and we'll keep working from there. So now that you're back, if the annual interest rate is 6%, then what is the monthly? If annual is 6%, then to calculate monthly, we've got to take the 6% and cut it into 12 pieces to make what's going to happen each month. We can do it a couple of ways. We can do 6% and cut it by 12. So I'll grab my good old calculator here. And I kept my units on there to help me know how to write my answer. So if I do 6 divided by 12, I get 0.5%. Now that is not 50%, it's not 5%, it's not even 1 full percent, it's like 50 cents. It's half of 1%. I could go ahead and move the decimal over for the 0.06 and then divide by 12. And we'll go ahead and do that. 0.06 divided by 12, and that's going to get us 0.005. And so the thing to notice is to really understand what you've got, that it's less than 1%, and that if I go to convert it, I've got to start at the decimal and move over, oops, went the wrong way, and move over 2 places, and that'll get me my 0.005 or my 0.005 here. So a final answer on this one is, how much is it going to be per month? Well, it's going to be 5/10 of 1 measly percent. So over the 2-year term, 2 years, how many times is the bank going to pay interest? And with compounding, they pay it every compounding period. And in this case, it's getting compounded monthly. So in the first year, they're going to pay you 12 times. The second year, they're going to pay you 12 times. So they'll pay you, well, it says how many times will the bank pay interest to you. They're going to pay interest to you 24 times. But I like lazy, and so I've got 2 full years. I've got 12 months for every year, and 2 times 12 gets me what I need. Or we can even go back to dimensional analysis. If I have 2 years, I need to know that I have 12 months for every 1 year so that I get my units of years to go away. And there's my 2 times 12, but we'll default to just the lazy way every time. And then also I got to keep in mind, if they're paying me monthly, I'm not going to write down 6%, I've got to write down the value for every month. And so I've got to keep that in mind, that whatever my rate is, I'm going to divide it by whatever my compounding period is. And we are going to end up having a special number for that, or letter for that. I'll wait on that for just a second. So it's always good to read the objectives. We are looking for the characteristics of exponential growth, and we are going to use the compound interest formula, that formula we've already looked at, for different compounding periods. So we're going to take what we already know, and we're going to move it into something new. But before we make that transition, it's really good when you can understand the concept. And so here is a question number 3. It would be really, really good for you to stop the video right now and go ahead and fill out for 1 month, 2 months, and 3 months. it would be really good to go ahead and filling those out. Know that you're using the principal of 1,000, an interest of 6%, 2 years, and then monthly. Well, they're working us through this, and then they're eventually going to get us to, let's do 12 months, and let's do 24 months, and 24 months, that is going to be our 2 years. And so just realize that what this is doing is scaffolding, helping you to see what and the why behind what we're doing, and then we'll go to the next page and come up with a nice formula. But it's going to be really important to know what the pieces and parts are that belong in that formula. So we're going to play around a little bit, and I don't have enough space to write, so I'm going to bring over some paper. And I'm going to write in here for 1 month. What is going on for 1 month? And so what I'm putting on the paper is what's going in this middle portion here in the calculation portion. I just need to write with markers to be on the document camera, and so I can't fit it all in there. But we know from the past that the accrued interest, compounding, so, I'll go ahead and say, on the compounding, I'm going to take the amount accrued here and then repeat the process here. Then take the amount accrued here, repeat the process here, etc. And that's going to be great as long as I'm going month by month by month. But this 6-month thing, yeah, I'm not going to want to keep doing that. But I'll play along for right now. So starting here with our first calculation, I think you agree that we're going to take the $1,000, and with our $1,000, we need to add a percentage of that. And the percentage of that is going to be this amount up here that we talked about. That's the monthly amount. But I'm going to go ahead and write it out that we're going to add to that a 1,000 times that 0.06 divided by the 12. If we were to multiply this, it's going to get us the answer that we want. However, they're trying to get us to discover what is going on here. So we're going to play around with this, and we're going to come up with a pattern. In other words, I've really got 1,000, a whole 1,000, plus another 1,000 times, well, we already know this is 0.005. We already played with that up here. Well, some of y'all sent me questions about distribution. Well, I've shown you how to distribute and then how to factor out from the distribution. When you go to factor out of the distribution, you're pulling it out and you're dividing out the same amount. And so when I take 1,000 divided by 1,000, I get just a 1. And when I take 1,000 divided by 1,000, I get 1.005. And a really lazy way to write that is 1,000, oops, you can't see that, times, when I add these together, I get 1.005. And you're like, oh my gosh, that took forever. Well, I'm going to put it to the first power. And this is a great place to stop the video and think on this, because the amount accrued, when I actually multiply all of this out, is going to be $1,005. Well, I really don't even care about this, because that amount is shown right here. Before I multiply, this is the amount. And to go to the second month, I'm going to wash, rinse, and repeat. I'm going to take this answer, which is represented right here, and I'm going to do the same thing. I'm going to take all of this, and I'm going to end up multiplying it by, let me find a shorter version. I'm going to end up multiplying it by this amount here. In other words, for the second month, it's going to be this amount, which is where we started, times that amount again. Up here we were playing. Well, we're just going to cut to the chase. Then I take my amount, until I can't see that. I take my amount, and I multiply it times this number, which was the 1 plus this monthly amount. And for my second month, I need to multiply in another one. Well, when I do that for this second month, that ends up getting me 1,000, and this is going back to some algebra. where you take the exponents and you add them. So in other words, right here ends up being 1,000, what did I write down, times 1.005, and it's actually to the first power. Then when I multiply in another one, which was this times another one of those, I get 1,000 times 1.005 to the second one, because it's now the second month. And as you might predict, when I throw in a third one, it's going to be 1,000 times 1.005 to the 3. And that's all wonderful and beautiful. And I'll go ahead and calculate this one. And so to calculate this one, clear, I'll do 1.005, send it up to the third power, hit equals, can't see that, times my 1,000 to begin with. And when I hit equals, that gets me 1015.08. So $1,015.08. Now, to keep going, like to the 24th month, I need to keep doing the 4th month this way, the 5th month this way, the 6th month this way, the 7th month this way, the 8th month, and y'all, I just don't have time. None of us do. So there's got to be a shortcut to what we've got going on here, so let's see if we can come up with it. So to keep going on all of this stuff, the shortcut, well, we're going to talk about the actual formula on the next page. I think we can see that the shortcut's going to be, since I'm in months, whatever my months are, if I already know and have put this formula together, I can just put the months in the exponent and it'll pop out the answer. So I don't have to keep doing first month and then move it over and do second month, move it over, do third month, move it over, do fourth month. No. And so the formula is going to very nicely turn out to be what you have here. And so at the end of the 2 years, because ultimately it's saying the compounding period's 2 years, doing this little scaffolding practice thing that we were doing, well, let's see what it would be at the end of 2 years. And so I'm going here, and I like to do mine backwards, so I'm going to punch in 1.005 and send it up to the 24 months. And then I'm going to multiply it times 1,000. And that gets me 1127.16. 1127.16. And again, this table, it's great, and you need to spend some time thinking on what in the world happened here, and that we keep moving this one down and doing another, etc. And that gives you the how and the why and what all is going on. But ultimately, you don't need to go build a table every time. You definitely don't need to do it for every month, one all the way down to 24. So there's got to be something that's faster. So glad you asked. Going on to your next in-class student page, number 4 says, write a general formula. Because when we go into a bank, the percentage is not going to be 6. It's probably going to be lower than that. And you may not want to put in 1,000. You may want to put in $500. You may want to put in $50,000. These variables are going to change. You may not want to leave it in there for 2 years. You may want to leave it in there for 8 years until your child gets to college age. I don't know. They may not compound monthly. They may compound quarterly or annually. All of these things are going to change. So there's got to be a formula. So ideally, right now, you cut the video off. Ideally, you mess around with a formula, and you keep trying that formula to come up with this answer right here, not doing all of this, but being able to take piece of information, stick it into some kind of formula, and bloop, out comes 1127.16. So in our formula, we definitely need P for principal. Our interest, we're going to call it like we did in the last lesson, R. It's a rate. Our term, that's still going to be our T, our time, in years. But then we got this new guy, a compounding period, and we're going to call it N. So let's back up and look what we did here. And I'll even put, well, let me start from right here. Let me just unfold my paper. So let's see if we can come up with a formula from here. A equals. Instead of just calling it 1,000, what would we call it? Well, write down P. And then we get this piece in the middle, and then we get this piece up in the exponent. So let's go to this middle. Remember, we started with right here. We started with a 1 plus. Well, that looks familiar. That was in our compounding interest formula. Okay, but we use P times 1 plus R, but our R is different this time. It's not based on annual, it's based on the period. And if you look right here, we took our R and we divided by the number of periods, and that's what we're going to write down. We're going to write down it's going to be R divided by N. No biggie. I just got to be able to identify it, write it down, and plug it in carefully. So we're almost done, except what about this number up here? So this number up here is going to still involve T, because you had T in your last formula, remember? P times 1 plus R up to the T power, and T must be in years. But in this case, we got to bring in the compounding periods, and I'll bring you back to this one right here. 24. How in the world could we get 24 when it's 2 years monthly, 2 years monthly, 2 years monthly? There's my 24. My T times my N. And so looking here, it's going to be T times my N. So jot this down. And yes, you need to memorize this formula. It's really, really nice. It's really simple to memorize. And then let's play with this formula. So playing with this formula, let us go back and just start from scratch. The original problem said this. So let me fold my paper this way to hide our old work. And I'll fold it hopefully so that you can just see the new work. So here's our formula. And here's the original question. So realize we started this lesson doing this way. We're like, oh, let's play around with it. Oh, let's see what's going on. And then we're like, we do not have time for that. So let's go straight for the formula for compounding interest whenever the compounding periods can change. And so looking here, I'm going to go right here. My formula is A equals. P is going to be a 1,000. 1 is a 1. R is 0.06. N is my number of compounding periods. So be real careful. Compounding period if it's monthly. Compounding period per year. And then when I go up here, it's 2 years times the 12, because the N is 12 of these in a year. So one thing I like to do when I'm solving it, I'll go ahead and multiply these two and call it a 24, and that saves my keystrokes. Another thing I like to do is I like to go backwards. In other words, I start from the inside, clear, clear, clear. I start from the inside and go out. So I'm going to start right here with 0.06 and divide it by 12 equals. I'm going to add in my 1, and hit equals. Now I have the guts of this parentheses, and you're like, wow, that looks familiar. Yeah, it does. It's back here where we had this 1.005. So we're on the right track. And then all of this parenthesized work needs to be sent to the 24th power. So send it up to the 24th power. And then the last thing, times 1,000, times 1,000. And when I get done, voila, we have about 1127.16. And that gets us straight to our answer of 1127.16 without having to go through the table and generate all of this. We just went straight with the formula, plugged it in, calculated it, and we're done. But let's play this with this one more time. Let's say that when you got to the bank, they had quit doing the monthly compounding periods. And, you know, let's play around. Let's just go with a whole new problem. So let's go with a brand new problem. I'll set it up, and then you cut the video off, and you punch in an answer, and then come back and let's look at it together. So let's go to the bank, and this time our CD is going to be quarterly. We'd like to leave it in there for 5 years, and let's go ahead and keep that 6% interest rate. It's what they offered us, and let's still just play with it for $1,000. So your time to cut off the video and your time to calculate something and then come back on the video and see if we match. And so hopefully you're back. And let's start with the formula. Here's my formula that I have memorized. My principal is $1,000, 1 plus. My rate is still in decimal form 0.06. My number of compounding periods, since it's quarterly, has changed to 4 in a year. My time is 5 years. My compounding period per year is 4. I am ready to do some calculations, but I like to go ahead and call this 5 times 4, 20. Again, I like to go backwards. I like to go backwards on calculations, and so I'm going to do the same thing here. I'm going to hit clear a bunch of times, and I'm going to start right here at 0.06. 0.06 divided by 4, hit equals, because my calculator is dumb. Add in 1, and hit equals, just to tell the dumb calculator this is all my stuff on the inside. Now this is not 1.005 anymore, because remember our compounding period changed. And my focusing froze. Oh no. Okay, it's back. So now I'm going to hit it up to, what is it? 20, and hit equals. I've got this, that, I need to do times 1,000, hit equals, and we're talking about compounding quarterly for 5 years, 6% interest for $1,000. We're going to have an accrued amount of about $1,346.86. So great job, but one last question. On your piece of paper it says if the compounding is done more often, what is going to happen to the accumulated amount? And so that would be good to think on, mull around in your brain, but what's going to happen, and you can go ahead and hit stop on the video if you don't want to hear yet. But what's going to happen is the more compounding periods, the higher the accumulated amount. And you can definitely play around with these, because if you do this, like even the problem we were just working on, if you come back around and in this case you change this and do it annually, annually would just be a 1, and it would change this to a 1, it would change this to a 1, and look at it, compare that this was quarterly, this is annually. You could also compare it to monthly. You know, start looking at the more my compounding periods, what's going on. Oh, and you could even do it weekly, and you would use a 52, because 52 is the standard number of weeks per year. So the answer is the more compounding periods, the higher the accumulated amount. So this ends our lesson in Foundations of Mathematical Reasoning for Lesson 19A.